really explaining why the number went where it did in the equation, okay? So we're going to have that discussion in just a second. Then we're going to go over the understanding check. I already made scans of it, so you can actually write on your understanding check in these pens. And I'll pass these around in a minute. And then equivalent representations out of the book. So we'll finally get back to the book today. So remember, you're going to have an understanding check tomorrow on how to write the equations of linear and exponential functions. That's the understanding check. That's what we worked on 2 days ago and the day before that a little bit. So you need to be asking questions if you don't know how to explain these equations. So that's what this homework is. We already went through the first like 4 or 5 of these. Z, where's your assignment? I'm still looking around. I see people that don't have this assignment out. How are you going to ask questions if you don't have this assignment out? I literally even reminded you all of that when the calculators weren't working. So, what questions, which of these problems, and this is what the bell ringer was, just which of these problems do we need to ask questions about because we don't know how to explain the equation? Because if you don't know how to explain the equation, when you get to that understanding check tomorrow, you're going to struggle in writing the equations. Are we good in explaining the equation for number 1? No questions. Number 2. Remember, this is the practice assignment from 2 days ago, guys. Writing the equation of linear and exponential functions.
Oh.
Okay? Remember, this is literally part of your active collaboration, the whole class discussion. If you need to ask a question, this is a great time to ask it. But it sounds we're good on 2. Number 3. Okay? One thing before we get too much further, I do want to remind you, if you're going to write the equation for a function, what is the very first step you need to do to write the equation for that function? This note I'd probably make at the top of my sheet in color if you weren't aware of this yet. What is the very first thing you need to do? Not necessarily. The y-intercept would be very helpful. I do agree with that. But there's something that you need even before you identify the y-intercept. Hold on, you're talking over Sanaya. Let's let Sanaya talk and then I'll let you add on or push back on. Sanaya, so what are you thinking? Find out how much it's what? How much it's changing by, right? Rate of change. Now, we'll point this out. Rate of change is very important, right? But that's not the first thing. Now, you might need the rate of change for this. Okay, you might need the rate of change for this. But I don't need the rate of change for the very first step here in number 1. Naisha? Guys, you've got to identify the type of function first. Do not forget that. Like, that's one of the most fundamental things. Because if you know the type of function, you also know what immediately? The equation, the formula to use, right? You've got to recognize that the very first step is you got to know the type of function, which is why we had the understanding check yesterday that we're going over today. If you're going to write the equation for a function, you got to know the type of function. You got to know the type of function. Okay? Which is why, right, so I was saying, in a table like this, what is the easiest way to identify the type of function? In a table. Looking at the what? Not y-intercept's not my doesn't tell me the function, because remember the y-intercept, or there's a y-intercept in both linear and exponential. What's the difference between a linear and an exponential function though? Repeated addition, the rate of change, or we have a constant additive rate of change, repeated addition, or we could have constant multiplicative, right? Our constant factor, which makes it exponential, right? So that's my point, is like in a table, I would need to identify that rate of change, but when I look at a graph like this, do I need the rate of change to know what type of function that is? No. I very clearly can see right away, hey, that's an exponential function, because it's an exponential curve. Do we need to talk, what is this, number?
That's number 5.
Number 5? Other sheet, see. Do we need to talk about number 5 at all? I think we talked about that one in class already. Okay. Number 6. Okay. I will point this out. Okay, listen very clearly on this. And don't forget this. It's hard sometimes when, what representation is this? Well, representation. It's a verbal representation, right? It's sometimes hard in a verbal representation to recognize the type of function. Do you have to identify the type of function in a verbal? No. What can you do? You're mumbling, but I don't fully hear someone saying, what can I do if I don't recognize the type of function in a verbal representation? I could make a table, can't I?
Yes, write it out.
Right? When you say write it out, you mean make a table? Okay, make a table. Could you make a graph out of that information? Yes? If you're not comfortable with the table, could you make a graph out of that table? Yes? I would recommend getting comfortable with tables, but you can always make a graph, so keep that in mind. Alright, but remember, this isn't right now about just identifying the type of function. This is about writing the equation. So, are there any questions through this one or this word problem about the equation? I think it was y equals 1 times 2 to the x here. I don't remember if we talked through this one at all. Right? We good on that equation? We did that one? Okay. Is this number 7? So do we need to talk about this equation at all? Yes? Okay. So what questions do we have about that, the equation for that function? What question do you have? Oh, I'm not asking did we cover it, I'm asking what questions do you have about how to write that equation? Because if you don't have a question, we're going to move on. Huh? Okay, so be careful with our language. I'm actually not solving anything here. So how to explain it? Okay, so anybody have an idea how to explain or how we got that equation? A place we could start? What you got, Jacoby?
Here, she gave out a secret on the first day to this friend, and then after that, like 2 more people knew about the secret.
Okay.
They gave me like 2 for like how much it goes for the time.
Okay, but why, and so I would agree with that, right? But on the previous one here, we also had a 2. So it's not just, oh, there's a 2 because it's changing by 2. Like, what's the difference? Why is this one 2x? There's a key to what he was saying language-wise about why it's 2x. Is that repeated multiplication here for number 7? It's what? It's repeated addition, right? Do not forget, when I'm talking about writing an equation, what's the first thing I need to identify? The type of function, right? That's what we just said. So when I look here at this verbal representation, you can tell each day 2 new people hear the secret. So what's repeatedly happening there? It's repeatedly adding. So I know it's linear, it's repeated addition, so what's the first thing I should do? This is what I want to get to, but what's the first thing I should have done to get to that point? very next thing after identifying the type of function. You could make a table. You don't have to, but you could make a table, and I will look at that in a second. There's one thing to do even before the table, though. Guys, if you know the type of function, you also know the equation, the formula, right?
Yes, sir.
It's linear. What equation can I write? There we go. Y equals mx plus b. There's also the option of a plus bx, either one. But we need to identify those different details. Now this is where a table could be helpful. A very quick table. We know day 1, how many people knew? Day 2, 2 more people heard, right? So we now have 4. And I'm going to point this out, like if you are not already doing this, whenever you make a table, look at the rate of change and note that rate of change on the table. Day 3 there were 6, because there were 2 more every day. Now I'm also going to put the plus 1 on the left-hand side for day. Does anyone know why I left a gap here? Right. I always want that y-intercept, don't I? I don't remember who mentioned it earlier. Jacoby, did you mention the y-intercept earlier? Right, we need that y-intercept. And on day 0, based on the pattern, how many people knew? Based on this pattern? Right, because we're repeatedly adding 2. Right? This is all evidence, Tevin, of why this is that equation. Right? So, then go back to the equation. How do I calculate n? What does that mean? And this is where we need to have our Venn diagram and why I'm not collecting it today. That's slope, right? Because we need to study these things. We got to know, okay, I need slope, which is the change in y divided by the change in x. Right? Notice we can do rise divided by run, which is what you're used to, but that's mostly for graphs. Change in y divided by change in x. Mickey, it looks like you have a question about that. No? Okay. So 2 divided by 1 is 2, because again, every day, how many more people are learning about the secret? 2 more. So 2 times x, which we can also explain that there because multiplication is repeated addition. There's a lot of details you can add into that, Tevin, right? And then plus, what does B stand for? Y-intercept. Now I do want to point this out. Is it because of this 0 on the left or this 0 on the right that I'm putting a plus 0? The right side. Remember, the 0 on the left tells me which value, which y value to choose, right? But I'm not ever using the 0 on the left. I'm not using the 0 from the independent variable. Tevin, does that answer your questions about how to go through that? Okay. Do we need to talk about, would this be number 8 then? 1 times 2 to the x? Say again? Okay. So I believe I told y'all that this equation was actually also y equals 1 times 2 to the x. So how can we explain that? Where is that coming from? Say again? Okay. What type of function? We got to recognize that exponential right away. What does that tell me? The equation. Which equation? There we go, right? A times b raised to the x. That's my general exponential function. That's where I start. Do not forget then that I need to clarify what these things are. And you could do this as a part of your justification. What do we mean by A? Just drawing a simple arrow down, this is going to help you think through how to write this equation. What do I mean by A? That's the what? That's the starting value, right? That's the y-intercept. What do I mean by B then? That's my rate of change. Specifically, what type? We know it's exponential, so we know it has to have what type of rate of change? Constant what? Multiplicative, right? If it's exponential, it's constant multiplicative. So, does anyone remember the name for that constant multiplicative rate of change? That's the type of rate of change, but it also had a name. It was a constant, starts with an F. Factor? Because what do we do with factors? We multiply them, right? So, there's a name for it. You don't have to know that. Could you just write constant multiplicative rate of change? 100%. There's a common letter, F, for constant factor, though, so that can help save you some time. But a constant factor here, and so we need those things, right? But that's evidence of your understanding. Not just being able to do a procedure, but being able to explain those things. Now, you can identify all of this just off the graph. You can. It's not easy, but you can. What else could you create though to make it easier? Table. What points would I have on this table? So I want the ones that intersect with the grid,
Yes, sir.
right? So which points? That's not 1 and 1.
Do 4 and 16. 2.
We need to pay attention to our scale. 2, 4, 6, 8.
Yes, sir.
So that's 1, 2. Then, what's next? 2, 4.
Yes, sir.
Then 3, 8.
And then 16.
And then 4, 16.
Yes, sir.
Anybody see my constant factor yet? What is it? Times 2. Notice I'm writing that times 2 out. Okay, because now I know, alright, so I still need A, but I know that I'm repeatedly multiplying by 2 to the x, okay? I need the y-intercept though. So I need when x is 0. What would that have to be? Wouldn't I need a 1 here so I can multiply by 2 to get 2? If you look at the graph, you see how it's right between 0 and 2? All those details go together. A y-intercept of 1 and a constant factor of 2. So notice, like, one of the things that you got to recognize is if you're trying to write an equation, personally, do you know what representation I think is the easiest to write an equation from? A table. At least for linear and exponential. Personally. Let me clarify that. I think a table is probably the easiest for exponential. A graph and an table are very easy for linear, right? Because you can see your y-intercept and your rise divided by your run. But I love tables for exponential. That's just me. You don't have to. Because you could have easily seen, if you had written this out, hey, that's 0, 1, 1, 2, 2, 4, 3, 8. Can you see in that y is just being multiplied by 2 every time? Right? So you don't have to make a table, you just can. Do I need to rewrite it somewhere, Phoebe, or make it bigger? Okay. Alright. I told y'all not to do this one, because I messed up. Do we need to talk about number 10 at all? We pretty good on that one? Okay. I will point out this. At minute 0, how much water was in the pool? Looking at the word problem. There's 5 gallons, right? Okay. When I had 5 gallons of water in the pool, I started the timer. That's why the y-intercept is what? It's 5, 0, 5, or 5, right? And then what's happening to that 5 gallons of water? Every minute, adding 2. So 5 plus 2x, because it's starting at 5 and repeatedly adding 2. That's why it's 5 plus 2x. That repeated addition is showing up through what operation? Repeated addition is showing up through what operation?
Operation.
Operation, right? That repeated addition is showing up through what operation? Listen to the question again. Repeated addition is showing up through what operation? Thank you. Multiplication. There we go. That multiplication is what tells me it's linear. Alright. Jiminy Cricket, 3 feet away from his house when it starts to rain. I think this may be a little bit harder. Do we need to talk about number 11 at all? Or are we okay on this one? Jalen? Huh? Let's talk about it. Okay, let me ask this. For those of us who need to talk about it, did you make a table yet? No? Nope. Okay. Let's think about that table then. Yes, sir.
Hey, you send me that worksheet that you're going to understand this working problem.
Oh, I have not yet. Do you want me to send it to you right now? Okay. Yeah. If I just give you a hard copy. Okay.
I just wrote it on.
Package. can send it, email to you later, but this is the, you wanted the practice, right, or did you want the understanding?
Yesterday, it's like 4 graphs, 4.
Ah, gotcha, the understanding check. That's not what I haven't seen my thing. It's open right there. And I'll email it to you as well. Okay. I'm sorry. Alright. So, hopefully y'all were making this table while I was getting that written. If I'm looking at this, right? So let's say jumps and distance from house. When he's made 0 jumps, how far is Jiminy Cricket from his house? 3 feet, right?
0.
After 1 jump, how many feet from his house?
1.1.
Is what?
Wait.
I've heard like 6, I thought 4.5, I heard 1.5.
That's 1.5.
1.5, why is it 1.5?
Oh, it says that he is half the distance to his house.
He's half the distance to his house, right? So he gets closer. So what operation can I show on this table for that? Times 1/2, right? And I would write this as 3/2, because here's the thing, you could use a calculator. If you're using a calculator, decimals are fine, right? But if I'm trying to do this by hand, and I multiply by 1/2 again, what's 3 times 1? 3. What's 2 times 2? That's all you gotta do to multiply fractions. You multiply numerators, you multiply denominators. So after another jump, a third jump, 3/4 times 1/2, what would that give me? 3/4 times 1/2.
3/8.
Say that one more time, not 3 over. 3/8 or 3 divided by 8 for me, please, thank you. Right? So notice, look at that equation. What was the equation I told y'all? Y equals 3 times. Do we still need to explain it? Or does that make sense? Like, I'll be more than happy to explain it further. But does it make more sense now with that table? So, this is a great question from Aisha. On an assessment, Jalen, math, not fixing our hair. On an assessment, would this table give me evidence of your understanding why this is the equation? 100%. Now, a quick note of y-intercept. Y equals a times b to the x, right? Times 1/2, my constant factor, there's my equation. That table is a huge amount of evidence. You don't have to build an equation off of a verbal representation. You can make tables, you can make graphs, you can make pictures to make sense out of it. I'm not saying I would do that in this case, right? But I mean, like, you could. I could represent how far Jiminy is from his house by doing, okay, so 3/2, right? I could then split that in half. Right? And I get 1.5, right? You can do any mathematical representation to make more sense out of what's happening, okay? All right, what are your questions before we continue to the understanding check?
Would that be full credit, like on the table, like a,
Which one?
do you credit, like just put the table down?
Just a table?
Like a full plus?
Just a table, I would say no. Including details of like, now also do remember, a 4 plus is not full credit. Does anyone remember what full credit is? Just a 4. A 4 on its own is full credit. But you also have to remember that is not, that rubric, and we gotta change our mindset, the rubric is not your grade, that rubric is what level of evidence of understanding. If you go look at the rubric, a 4, Preston, I think you have the rubric right there in blue, right?
Yep.
What does it say for a 4?
Or a 4.
Yeah, what does it say there for a 4?
Solution/response is valid and the justification is justified thoroughly.
If you have a valid answer and you've justified it thoroughly, isn't that full evidence of understanding? So what's the difference for a 4.5, or 4 plus, sorry?
Solution and response is correct, the response is justified thoroughly, and there's extra evidence related to the concept.
Extra evidence, right, going beyond. Does that make sense? So like, it's about your evidence of understanding, and I'm gonna show you some of that with your understanding check, right? So we should have out a colored pen, to be able to look at the understanding check at this point. Hopefully I present a remote. Yes, that is yours, to study for the understanding check tomorrow. The homework assignment, was it Trayana who asked? Trayana asked, yes, that is for you to keep so that you can study for the understanding check tomorrow. Without it, you'll be in a bad spot. Okay, I'm going to, anybody see my black presenter remote anywhere? Okay. I don't know, I can't find it. The black presenter remote? The clicker?
Under there.
Under where?
Wow.
Oh my gosh. I cannot believe that I fell for that. Oh man. Thank you. Alright. So here is numbers 1 and 2. That should say linear right here. What questions do we have? Notice I will point this out. This is not justified, right? These are just the final answers. I'm going to do this for each one of these questions. I'm going to show you the final answers, and then I'm going to see if you have any questions so we can talk about it before I just show you my justification. Quadratic and linear. Questions about that? Okay. By the way, no pencils on desk at this point. All pencils cleared off. Put the pencils either in your backpack or under your desk. We should only have out our colored pens. If I see a pencil on desk, you get a 0 for the understanding check. Right? Trayvon, is that a pencil right there?
Oh man.
Thank you. Okay. So, this is your understanding check to take any notes you want before I score them. So, when I look up here, right, no questions about why quadratic or linear.
How does it quadratic?
The number 1? Okay. Anybody want to tell us how we know it's quadratic?
You.
Pause right there. I want to point this out. It's a curve, right? Is that a curve? Is that all we need to say? Say that one time. It's a parabola. Remember, the quadratic curve has that special name of it's a parabola. Be careful with the idea of a U shape. Is a U shape clear mathematical language? No. So is that full evidence of your understanding? No. Okay. But it's a parabola, so it's a quadratic function. That's literally what I explained. Quadratic function, because this is a concave down parabola. If you just said it's a parabola, I would say probably a 3 plus, the concave down parabola, that's what gets it to a 4. Huh? To get to a 4?
So I just got that right.
You said we didn't put concave down, we did what?
It'd be a 3 plus.
Oh, I put concave.
What about?
I put concave.
So if you just put concave, hold on. If you just put concave down, that's, and here's the thing, guys. We're focused on improving understanding. So if you just said concave down, put parabola. If you just said parabola, put concave down, right?
I put concave down parabola.
Okay, so then yeah, that's looking at probably a 4 if you said it's quadratic because it's a concave down parabola, right? Okay. Say again. There is no 5. There's a 4, and then the only thing above that is a 4 plus. Now, if you're asking what a 4 plus would be, remember Preston read it out. He said it's extra evidence. Here's a small piece that could be extra evidence. Quadratics are the only thing that have that point. What's that point called? A vertex. Well, that's just a vertex. And it's a line or axis of symmetry. That could be the extra detail that you throw in there to earn a 4 plus. But remember, guys, what is complete evidence of your understanding? What level on that rubric? What level on the rubric is complete evidence of understanding? A 4. That's it. That's all you need for complete evidence of understanding. That's the extra detail that would get you to a 4 plus. Okay? Here is something I need you to hear me very, very clearly on, though. If you said anything about number 1 being a line, you're getting points, or not points, you're going to get a C on your understanding check for a conceptual misunderstanding. Is number one a line? No. What two words, there's two different words that I would accept here. Not a line, but one of them starts with a C. It's a curve, right? That curve is a parabola. You can't say it's a line. You could also say that the graph is a parabola. But if it is a curve, do not call it a line in that classroom. Or period. It's not a line.
Period.
Okay? Number two is a line. It's a linear function. It is a line. Okay? I will point this out. Linear function, graph is a line. Boom. That's complete evidence of understanding. You don't need any more than that to show me complete evidence of understanding. This extra detail, the constant additive rate of change, a slope equal to -3/5, that's that extra detail that would increase your evidence of understanding in my mind. That would be some evidence. I wouldn't say that puts them to a 4+ though. Like if you're going to say it has a slope, then tell me what it is. Okay? Alright. So, I went a little bit slower through 1 and 2. From here on, the conversation will be driven by the questions that you have, except for a handful of small details. Numbers 3 and 4, exponential function, and number 3 was none of the above. Either of those that we need to talk about.
What if I put none of these?
None. For number 3, yeah. So none.
Yeah.
That's an extra small detail. We're actually going to talk about that a little bit more today.
I said neither.
Yeah. Well, okay. Did I have neither? Well, the reason why you would need none instead of neither is neither means it's not. It's only one of two. We had 3 options. That's why it was none. Right? That makes sense. I'm not gonna. I'll say this. I'm not gonna knock you on that, Phoebe. But just be aware that's why it was none and not neither. Okay. All right. So. We'll talk more about what it means to be a function later, so don't sweat that. That was supposed to be something we'd already covered, but I had to slow down so that we could practice writing equations on Tuesday. Do notice that extra detail of, hey, there's my constant factor. If you made a table, you could take a number and divide it by itself, but repeatedly multiply by 2/3.
What, can you go back real quick?
Say again?
Can you go back real quick? Whoa, whoa, whoa.
No, so hold on 1 second. So the reason I'm going to say no is we got to get moving. If you want to write this down, when I give it back to you, the notes are on Schoology.
How are we coming on to the
You're going to give it back so that I can score it, and then I will give it back to you, and those notes, all that information will be on Schoology, so that, and I'm going to create, I've never done it before, I'm going to create a new folder within each unit that is assessments solutions, and that'll be there. The idea is this, because I did notice, I should have mentioned this, I saw quite a few of us who are like halfway through this understanding check. We got to move quicker than that. And so we need to be more efficient with the way that we're writing and timing and things like that. However, with the way that I score, only finishing half is not necessarily earning a 50. It could be higher than that depending on your evidence of understanding elsewhere. However, even if you made a 50 on this understanding check, is that your final grade for this assessment? No. Why not?
Because you'll just go with the test.
I'm going to recheck on the test. So if you show me improved mastery on the test, I'll honor that. So keep that in mind. Say again.
How many points did you say that was?
The understanding, don't sweat that. I'll explain things about that later. Understanding checks, I always equate to however many points we have for active collaboration during that time, right? So if we've been working on something for 2 weeks, active collaboration is roughly 40 points, the understanding check would be worth 40 points. But the test is scaled in a corresponding way as well, and again, if you make the test, if you made a 50 on the understanding check and a 95 on the test, 95 takes the place of that 50, right? So it doesn't, you learn from your mistakes and you grow. That's the priority.
What thing in there?
What?
In the grade book.
What thing?
The grade.
What grade? Be more clear with your language.
Never mind.
Okay, I just don't know what you're talking about.
What you was just talking about?
The understanding check?
Yeah, I guess so.
The thing that y'all are working on right now?
Yeah.
The thing that y'all took yesterday when I was out of school, so there was no way for me to get it until this morning. I graded it this morning.
I mean, I don't know what you be doing. You might. I don't know.
Dude, I give feedback to y'all when I score understanding checks, and I'm behind on things, but no, I have not gotten to it yet. Here are the answers for 5, 6, 7, and 8. You thought 8 was what?
Says so linear.
Well, I remember, there's justification that I don't have up here yet.
Quadratic. Oh, I got that one wrong.
So I haven't put my justification up here yet. Are there any of these that we need to talk about because we thought it was something else?
The number 6.
Number 6?
Yes, sir.
Okay, what about number 6?
I put exponentials because I said use, and because I had circled the exponent, that's why I messed up it, and then I thought it was.
But do you understand why it's quadratic and not exponential now? Okay, can anyone explain, hey guys, being able to explain is important. Can anyone explain why number 6 is quadratic and not exponential? Remember, that's just function notation. We can use function notation for any function. Okay, pause for a second. This is a good point. Hold on a second. Listen. Does a quadratic function have linear additive rates of change? 100%. Can you see that in this equation?
Yeah.
There's only one representation really that shows rate of change easily. The tables. Tables. What in this equation tells me it's quadratic?
Exponent.
Which exponent? What type of exponent, huh? The highest exponent, known as the degree. Remember, what is the exponent for an exponential? So a variable, right? So an exponential has a variable in the exponent. That's why it's repeatedly multiplied by 2/3. This has a 2 in the exponent. It's a second degree polynomial is what we call it. We'll talk more about it later. That's why it's quadratic. And so here is the information that I wrote with it, right? Notice a times b to the x. And by the way, guys, you don't have time to write all this down. I would focus on learning. You can write this stuff down or just add in small details you're missing. Yes, David.
So if I explain how quadratic or exponential,
So you made a procedural error in the idea that you told me it was exponential, right? But you showed me some understanding, right, that it was had that exponent too. So I would have to look at it more clearly to be able to make a decision. But it's probably my guess either a 2 or a 2+. That's my guess. Okay. All right. I will point this out, and this is something I saw a couple of students already. And so, Jose, I did glance through these to see what things I might want to talk about. Right here, that plus does not tell me that this is linear. What tells me that 8 is linear? Not the x.
So,
3/4 times x. You can have a fraction like that in other situations. In fact, Jose, right here I have a fraction. So how do we know that's not my slope rise divided by run? Well, because it has a variable exponent. Why do I know that that's my slope? Because the slope is being multiplied by the variable. That multiplication is constant addition, right? That's what we want to remember and always note, right? That we are looking for that multiplication for that constant additive rate of change. Okay. All right, numbers 9, 10, 11, and 12. We got exponential, we got quadratic, we got none for number 11, and 12 we got linear. I assume we need to talk about number 11. Yes. Look at it. I probably should rewrite it over here to make it a little bit bigger. I should have split this up. If we look at number 11, and I knew that some of us weren't paying attention to this detail, which is why I made this problem so that we can learn from it before the unit test. How many of us thought that number 11 was linear? A lot of us, right? Because it was repeatedly adding 1. Yup. But look at the left-hand side. -8, -4, +4, +8. Is that also constant additive? No. That's actually a linear additive, which is going to create what's called a square root function that we'll study later. Don't sweat it right now. Because remember, if it's quadratic, it needs to be linear additive on the y. But we got to notice, we got to pay attention to, you cannot just look at the y values. You have to look at the x and the y. Right? It has to be constant additive on both. And that's a note that I would definitely make if we miss that detail, that for it to be linear, it has to be constant additive on both sides of that table. And we're gonna talk about why it's not a function in a minute. Right. So that's why I made the note, this is not constant additive, so it is none of those. What are your questions about the 9, 10, or 12 though? No other questions? We'll go on 9, 10, and 12?
Which one?
Do please note with 10, right? I looked at that rate of change. A lot of us said linear for 10, or a lot of us will say linear for 10, but this is constant additive, so the rate of change is linear additive. Do not forget, the rate of change is the first set of differences. That is not, in blue, that is not constant additive. This part is constant additive, so the rate of change is linear additive. Do I need to clarify that to explain why it's quadratic? Also, I'm realizing looking up here, it's not the largest. Do I need to turn the lights off so that we can see it more clearly?
Yes, sir.
Okay, y'all can ask that, yeah. Hit it, nice. Is that better? Helps it pop a little bit better?
Yeah, that's good.
Yeah. Alright. So, note, if there's no questions, I'm going to continue. Remember, I'm going to put these solutions on Schoology. You can make some quick notes until I change slide, but questions, comments, or concerns? Yeah. Go for it. I want that. What? Notice this pink part is constant additive, but that means this blue part, the rate of change, what's always to the left of constant addition? Linear. So this blue rate of change is linear additive rate of change. So the function is quadratic. So guys, it's not just, oh, there's constant addition, it's always linear. You've got to make sure that, and remember that the first set of differences, right? The first set of numbers that you write, that's the rate of change. And so I had to pay attention to the blue for that rate of change. 13 and 14, linear and exponential. Questions about those? Notice I just made a quick little table. You can always make a table. What? Don't forget, it's not just about getting the answer, it's about justifying it. I will say this because I did already see a couple people try to write equations here. Please note this equation would be 55 plus 35x, not 55x plus 35. That's what this equation would be. I'm not asking you to write the equation here, but that's what you would want to note. Why is it 35x and not 55x? Hold on, you can start. Then you can add on. What? I need more than just that. When you say rate of change, can anyone add on to that 35 is the rate of change, that's why it's 35x. It's repeatedly being added, right? And so you're 100% right, that's the rate of change, but I need more clarity with our language. It's constantly adding by 35, so that's why we multiply, right? Starting value of 55. Where? Yeah, 90 plus 35, because we're repeatedly adding 35 every time, right? So that constant added rate of change by 35. Okay. Are there any final lingering questions about identifying linear, exponential, or quadratic functions?
Right there.
Say again?
Is that 1/2?
This part, this initial?
Yes, sir.
Yeah. Notice after 1 minute, he was at 1 meter. Then he started to double, right?
Yes, sir.
And so it's not realistic. He really started at 0, but in the context of this, we would have to say his distance was 1/2, and then he was doubling that, right? So the idea that it was constantly doubling, yeah. Okay. All right. We're going to move on to the book now. Volume 1 of the textbook. Let's get that out. We want to go to M1-31. This is lesson 3 in the very first unit. Oh, please put your understanding checks together in the center of the desk so I can come and collect them. Okay. Yes, sir. Huh? I don't have. We're gonna have to tear something out of it. M1-31, so you'll have to work with your group members, okay? Yeah, M1-31. Huh? I'll come and collect them. Hey guys, please just leave the pins on the desk. Do not take them with you. I'll come and collect them. All right. So we are on M1-31. And please note these key terms. You need to know these key terms. But Samesies is all about comparing multiple representations of functions. Okay. So there's a lot within this. The very first one, please note, is I can identify functions versus relations. We're going to define those things and talk about them in a second. But a lot of this, right, is stuff we've already been doing, right? Identifying linear, exponential, and quadratic functions in each of the representations. This has helped us practice developing that. And then I will say this is probably the last task where we will be developing that, so we need to make sure we're really working on it. Identifying equivalent forms of functions. What do I mean by equivalent? It's not quite equal. Say again? The same. So the difference between equal and the same is if they are equal, they are literally the exact same thing. But if we say they are the same, they could appear different, right? You can have a table and a graph. Do they look the same necessarily? No. Could they represent the same exact function though? Yes. So that's what we're talking about when we talk about that idea of equivalence. They may look different, but they're still the same. And we're going to use some algebraic properties to generate equivalent expressions. I'll explain more about that later. So first things first, okay? In a minute, I'm going to pass out the scissors, and we're actually going to cut some pages out and cut out some cards from within the book. But before we get there, as you've always heard me say, what is mathematics? The study of what? Patterns and relationships. Notice the book literally agrees. Understanding patterns not only gives insight into the world around you, it provides you with a powerful tool for predicting the future. We want to look for patterns. And so each of those representations can describe the same exact pattern, but in different ways. And those different ways reveal different details about those patterns and those relationships. So, right here, you need to pay attention to the keywords of relation, function, and function notation. So what is a relation? Look at the book. Oh, by the way, this is another page forward. Sorry, I should have said that. M1-33?
Yes.
Yeah, so 3.1 is on M1-33. So what do we mean by a relation? So a mapping of input values to output values. Well, what in the world does that mean? Well, if we come back here, right here, you see how we have an input and we have an output? That's a mapping of inputs to outputs. Right here, every table. It's a mapping of an input, -3 maps to what output? -7. And so these are just the tabular representations. Here, I have the variable x and the variable y. When I substitute an x value in, what am I going to get out? Y value, right? So I get an input and an output. That's all a relation is. I get inputs and I get outputs, and graphs are another representation of that. So when we talk about a relation, that's just any input to any output. What's the difference between that and a function? It's in the book. What's the difference between a relation and a function?
The function that indicates that x is the output and fx is the input and fx is the output.
Is that a function or is that function notation?
Function notation.
So what's a function? Because if we're going to use function notation, we got to know what a function is, right?
Each element of the domain, there exists exactly one element in the range.
What in the world does that mean? Was that English?
No.
No, not for some of us. So domain, what do we remember about domain? We need to clarify that term. There is a range too, but what is domain? So the domain is the set of all x values for a relation. I would probably define that. We're going to talk about it, how to identify the domain later, but we need to know, yeah, M1-33, you got to know that a domain is the set of all x values for a relation. The set of all x values for a relation. So then what do we mean by range? All y values for a relation. Domain is the set of all x values for a relation. Your range is the set of all y values for a relation. Now I do want to clarify, and I do want to point this out. Can you have a function that's not x and y variables? It depends on the context. Remember when we did to use or not to use algebra, we used variables that made sense, right? We had B for bottle and C for cork, didn't we? We used something like T for trips and M for money or something like that in the second problem, something to that effect.
C for cost.
Huh?
I think it was C for cost.
C for cost, okay. So can we use variables other than x and y? 100%. So when I say x, what do I really mean? Thinking about the definition of a relation, when I say x, what am I really referring to? It's the set of all, is it my inputs or outputs? Inputs. When I say x, what I'm really saying is the set of all inputs. Keep that in mind. Because we can use other variables. X is the set of all inputs. Where y would be the set of all outputs. X is inputs, y is outputs. No matter what variable we're talking about, inputs and outputs. So it then says that every element of the domain then maps to one element of the range. Is that what it said? When it defined in the book? Yes?
Yes.
Each element of the domain maps to one element of the range. So let's look here. If I look at this table, -2, what does -2 map to? 2? Does -2 map to anything else? No. If I put -2 in for x, the only thing I'm getting out is 2. If I substitute 0 in, what's the only thing that's going to map to? 11. Over here, if I substitute 1 in, what does 1 map to? Does it map to anything else? No. But look down here. If I substitute 12 in, what does 12 map to? -5 and -1. You see how that one input maps to two different outputs? That's why it's not a function. We would say that this is only a relation, it's not a function, because one input is mapping to two outputs, or just more than one output. That's what we mean for a function. Each input maps to one and only one output. If one input maps to more than one output, it's not a function. And if it's not a function, it can't be linear, exponential, or quadratic, because that's linear, exponential, and quadratic what? Functions, right? For a function, each input maps to one and only one output. That's how I always word it. Each element of the domain maps to one element of the range. What are your questions about that detail? Which part? Each element, or I say that each input maps to one and only one output. That's another way to word that idea of the element of the domain mapping to an element of the range. For a function, each input maps to one and only one output. Now I will point out, this is a function, right? Each input maps to one and only one output. Is it a relation? A function is just a special type of relation. That's it. A function is just a special type of relation. This is not a function. Is it a relation? Yes. All a relation is a mapping of inputs to outputs. A function is a special type of that relation. Last thing I'll point out is here. Remember how I said this is not a function? Why is that? You can have functions other than linear, exponential, and quadratic.
It has to have at least one input and multiple outputs.
So to be a function, each input maps to one output. If I look at this one input, let's just say that's 1.5 in the x. How many outputs does it have? So it has 2 y values. So one input is mapping to more than one output. That's why it's not a function. It would only be a relation. Still has a mapping of inputs and outputs, but because one output, at least one output, or one input maps to more than one output is not a function. What are your questions about that? Going once? Going twice?
What the fuck?
Sold. Okay, so here's what we're going to do now in the book. Oh, and then please note, function notation, right? Do not ever read this as f times x, or if it's h of x, don't read it as h times x. You can use any thing, but if you see f parentheses and then an input, it's f of x. And that indicates that x is the input and f of x is the output, which is why a lot of times instead of f of x, we could put what for that output? Y, right? Remember, f of x is my output, so a lot of times we can put a y. Jose. That's what we want to note there, right? You can use any variables for that function notation, but the function notation is just useful. Okay. Number 1 says cut out the relations provided at the end of the lesson, analyze each relation, and then create groups of equivalent relations. The, nope, that's not what I wanted. Come back. Did I note to myself here? I did not note what page it's on. I need to fix that. So go to the end of the lesson, pages 41, 43, and 45. First tear those pages out carefully because you need those relations. So 41, 43, and 45. Tear those relations out carefully. Once you have your relations torn out, cut them out. 41, 43, and 45. I would just do it one at a time, but yes, it should. So let's cut out those relations, please. You need to cut out each, cut along dotted lines, cut out each relation. 41, 43, and 45. Okay? I'm trying to find out if I have any more scissors. It looks like I'm out. Let's cut efficiently. So yeah, Jamarcus, you're going to be doing the same thing. Cut them out, all 3 at the same time.
Cut
Right?
off all 3 at the same time.
So like stack all 3 sheets of paper on top. They should line up. Be careful and make sure they do. And you should be able to cut out the border and then just cut along those lines to cut all 3 out.
I don't know, man.
Okay? I know. I didn't have enough. So yeah, just in a second. Yeah. Here. Oh, I was like, why are you cutting your? I was like, why are you doing that? Sorry, I don't have any left-hand scissors. I guess I'm good shot this up.
Yeah, because I'm left-handed.
I know, but I didn't even realize there were left-handed. Oh, I found more scissors.
My mom and my sister.
They ain't no left-handed.
Yep. Tyson. Huh? Oh, you don't have that. Got it. Mini scissors, Desiree, and Mickey. You'll have to do the same as Tyson and just work with your group. Bring your book tomorrow. Take the calculator for it. You would throw that girl in the lights like that?
Oh my God.
If you turn them the right direction, they do go together. I'm sorry. Too bad.
Just like that, you know.
Huh? Mr. P. I figured out who you're talking about once I realized it was P that you said. I would never change it.
Oh!
I like your method. I like the math grade.
I was like, I've said a lot of them. I don't know which one you're referring to, but yes, sir. Did you mess up on the car?
Yes,
Be careful.
Thanks.
Oh my God.
Is there anybody's pins I have missed?
Yeah, you do.
I can't read. Thank you. Thanks, sir.
You got mine.
I just.
I'm sorry, brother.
All right, we need to have our relations cut out. Let's go, maybe 60 more seconds. Yeah, cut quicker. Huh?
I need a minute.
You don't know what goes what? This is the whole lesson. Is to figure out which one goes where. Okay.
What's wrong with that?
I'll collect your trash. Once I'm done collecting trash, we need to be done cutting. And cutting papers are hard. You need to get to the gym. I agree with that, David. Chevron here.
Why not Mel?
Ooh, David.
I trust Chevron gas motor. What just happened?
I've never lied to my
Scared to
wife.
know.
Yeah, David dreads are good.
Hey, yo.
Shut the what? Shut the
hold on
front
to
door,
it.
David. Oh my God.
Hey. Alright. Hold on to the scissors. I don't have so many hands. If I can get your trash though.
I don't.
So what's wrong with that?
That is not, it just doesn't look like what Thank you. Thank you. Thank you. Okay. So first off, Lily Kate, what was your question?
Aren't these the same problems?
There was a couple of the problems, the word problems that I did pull for the practice that we already did. Okay, but let's look up here. If you're still cutting, Continue cutting in a minute, but let's pay attention to these directions. So we have about 10 minutes right now. Okay, we have 10 minutes about right now that we're going to have to wrap up tomorrow. And I'll give you paper clips at the end so that you can put your relations together. But can someone read out the directions for number 1? Stop talking so we can read the directions, Phoebe. Okay. Really, Kate, you going to read for us?
Cut out the relations provided at the end of the lesson. Analyze each relation and then create groups of equivalent relations. All relations have at least one match.
So, okay. Yeah.
Provide a brief rationale for how you group each set of relations.
So, what does that mean we're doing right now?
Cutting out.
We already cut them out. What are we doing now?
Provide,
Know where they go.
Okay, when you say know where they go, what do you mean?
making sure they match.
Matching. So how? So what is matching? What are we trying to match?
No, we're trying to match the equation to the picture.
Okay. So we're trying to match equations to. You say pictures. What do you really mean by that? I don't think there's any pictures there.
The graph.
The graph. So is it only equations to graphs that we might be trying to match? No. No, it could be equations to tables, equations to graphs, and there are verbal representations in there. So David did bring up inputs and outputs. If a relation is equivalent, they have the same what? Inputs and outputs. They're describing the same situation. So we want to recognize that if relations are equivalent, the same inputs and outputs exist. Last detail is this. Note in number 1, it says all relations have at least one match, so there should be no singletons. Hey guys, please focus. There should be no singletons, but you can have equivalent relations up to, I think, 4 or 5, maybe even 6 at a time. So there are some that have, there's quite a few equivalent relations that would go together. All right, we're ready to start sorting. All right, let's get to work. We have about 10 minutes to sort.
Wait, how many of these do we have?
I think there were 8 on each page. 8 times 3 is 24. I believe that the last letter you should see is X. Yep. Well, if there's 24, there's 26 letters in the alphabet, right? So we don't have to do Z, we can just go through X. Okay. So guys, please do note you should have letters A through X, right? And you each, oh, I should mention this, guys. Listen. You each have a set of these, but y'all should be working on them together, meaning we're collaborating. But if you say, hey, I think I goes with S, talk about that and discuss it. Ooh, I think K also goes with that. So use these and pair them up or put them in groups. Say again. There's at least 2 in every group, but there could be up to like 5 or 6 in a group. By the way, Z, we need...
Don't slim the
Why don't we just turn the desk around and behind you? And so, why do you think X and F?
But O is the one that
So it doesn't equal anything. You're saying it's not a function, so it's just, it is a relation. But if we look at it, 0, 2 is that a point on that. Right, so that input and output is 0, 2 here. Not. 0, 2 is right there. Is 0, negative 2 here? Yes. It's harder to see, but 1, 1.73. So 1, could that be maybe 1.73? What do you see right there? So notice those inputs and outputs map. Notice they even set it up right here, right? Negative 1, 1.73, negative 1, negative 1.73. So you can see it's not a function right away. But there's a map. We'll try to see if there's anything else that maps to it, but keep working on that. How's it going?
Why are we missing all your
Well, because there's only 24, so we're missing Y and Z. But you should have everything else. Then you should check around you, see if anyone accidentally picked it up or if it went on the floor. Because you should have everything.
You know what man's word?
All the problem is I don't know my ABCs. That's a big struggle.
No problem. Make sure y'all are talking about it together. Let's help each other and try to figure out
Match these.
Yeah, look, see if you have an extra S, extra W, or an extra B.
That's actually
Or if you accidentally forgot to cut it out, that could be an issue as well.
Can't, which one's the G?
So, there were 3 pages, 8 each. So let's work together, let's focus on trying to identify, so you're saying that you and go together? Let's talk about it together, let's see if we think you're equivalent.
I look like OD.
Yeah, I agree. She does go.
Dude, you didn't even get what I was saying though, so
Okay, so Tevin's saying that in W, you don't see anything constantly adding or constantly multiplying, right? And it does kind of jump, right? But, okay, we can still maybe find an equivalent function. Also, you can leave it off to the side and try to find something else first, right? So if you don't like W, maybe move to I or Q, or even look at the equations first, right?
all of them is we missing 2 letters. We missing 2 letters.
I feel like it's oh, y'all, I found my S.
Awesome sauce.
Yeah, Louise goes. I feel like goes.
We need to look at T and A versus J again. Well, the line of symmetry is actually in both of those. How are we supposed to tell the difference? Which J goes with A or with T? That was nice.
In the head.
The extra information. And the graph open. So we're just focusing on the party. Alright? Have we identified anything that goes together? I will say this, it's gonna be hard if you have them stacked like that, Marshall. You will need them spread out to be able to identify what goes with what. Come on, we're 5 minutes in, we haven't really partnered anything up yet.
My bad, I was putting my thing out.
Still?
Yeah, I just got done living here.
Okay, let's get to work then.
I'm just calculating. My calculation predictions like I'm like.
So wait, you didn't see and you?
What?
All 3 of them go together?
Oh, that's how you spell parabola right there. I put parabola.
I don't even know what that means.
Yeah, I'm gonna come back and check on y'all. We need to start trying to identify
I got you.
equivalent relations.
I got you.
What if we put together the C, D, U, and S. So C, D, U, and S. How did we identify that combination together?
Me?
Do not see.
I think it's too cheap.
I don't like
I think Jay and I go to
Anyway,
Hey, watch your language, man.
If you look at the graph, if you look at the graph, you put 3 in there, put 6. That matches it. I'll also point out, does that match the equation? Like, you put a 3 into your equation.
I feel like S goes with
anyway.
Yeah, we just map it to the correct output, or like, sounds good to me.
I think
There could be some more, but, so always be aware, like, you can find some more possibly, but it looks like it's good. Check with your group, see if they all agree.
Hey, what about you and G?
Oh, y'all put them in the calculator?
Is that legal? Can we put it in the calculator?
Yeah, they don't go in there. You do that on
Sometimes. I'm gonna tell you, there are calculator and non-calculator portions of all my tests.
Oh, we need one for all of them.
Good enough.
All these plans is really hard.
I know, it's this thing where you have to think, right? How wild is that? Yeah.
You gotta use our brain for that.
Yeah. So, because the reason why it says F1 is because it uses F for every function. So F1 just means the first function, the second function, the third. That's all that one is doing. Okay. Everyone else. I know. I meant like you're not gonna group yours together though. I know you're engaging. I can see. I've seen it. and I've heard it. But I was just gonna point out like it might be a good idea to escape. All right, we got about 5 minutes left. We're gonna give you 2 more minutes to continue grouping, and then we're gonna have a wrap-up discussion.
Sabuya.
Actually, hey, can y'all do this for me really quickly? Leave your the cards where they are. I'm gonna bring y'all paper clips. Nikki, what are you doing? Can you listen?
Yeah.
Okay, leave your cards where you are. They are. Stack. Actually, do this for me. Stack the ones that go together, but make one pile so that you can easily sort them out tomorrow. I'm gonna give you a paper clip. After you finish that, I want you to go to number 1, and I want you to go ahead and put a brief rationale for how you're grouping these things. So this is just a quick note to yourself of, okay, tomorrow when I come back and do this, how do I continue this process? You could even write out which groups you've already identified, right? So if you put S with T, then you could write ST there. So you can quickly identify the groups you've already done, quick rationale.
In the book?
In the book, yeah. So M1-33, I believe.
Wrong job.
Hold on, too. Use it, I'll be safe for tomorrow. M1-33, guys. Note to yourself which relations go together. Note to yourself how you identified it so you can pick back up tomorrow. Thank you for following those directions. M1-33. I'm bringing by the paper clips now. Make sure you do not lose these cards, otherwise your job tomorrow will be real hard. You did not have your book with you. You need to cut out those cards tonight and bring the cards with you tomorrow to class. Alright, last detail, because it looks like most of us are packed up. Eyes up here. Hey guys, eyes up here. Dadgummit.
You just cursed?
I said dadgummit. So, please note your homework. You have an nope, not that I've got to update. Your understanding check tomorrow is on what? Writing equations of linear and exponential functions. Make sure you study and pay attention to, hey, I got to identify the type of function first, write out the formula, and then substitute in. It's not going to be as long as the last one, because I'm only going to have a few, because we only have so much time, but you're going to have 20 or 30 minutes to do an understanding check on writing the equations of linear and exponential functions. So you need to study and come in prepared, because that's all the time you're going to have, all right? We're going to come back and finish it. Your Venn diagram is due tomorrow.
Hey, Ethan, bye.
I think I'm gonna follow you where I can go.
Oh, okay.
Good morning, Kason. Yes, sir. The explanations of those linear exponential functions that I gave you, or equations I gave you the other day. That's due tomorrow.
Sorry. Oh, what you say? Are we talking about cars? Are we talking about cars?
Oh, don't talk about it. No one can see you.
You have books, you start don't put them in. Don't put them in. Yeah, not every talk to me like this. Don't talk to me like this.
All right, poll questions coming out. Sorry it took me so long. There you go. Good morning, Jamarcus. Yes, sir. No.
Are we doing arts correct?
Not arts and crafts, we were doing math. Good morning, Amar.
My bad. I thought you said you were.
I was helping teachers basically become better teachers. I was supporting teachers